Hello everyone, this is Shao Miller. I'd like you to imagine that there are two families in a town, the Smith family and the Jones family. And the Jones family has been given 9 gold coins at some point by somebody, and the Smith family has been given 1 gold coin. So in this town, let's suppose that there are only these two families, and therefore there are only 10 gold coins in this whole town. And then someone from out of town arrives and they introduce a contest which costs participants 1 gold coin to enter. Only one person will win, but then the losers will receive their gold coins back. So it's not quite like a lottery in that the losers get back their money, but it does cost money to apply. So now the Jones family and the Smith family have members that both want to participate, and so they pour in all of their gold coins in order to have a chance to win. Now, that means that this out-of-towner has all 10 gold coins, 1 from the Smith family and 9 from the Jones family. What are the odds, what are the chances of winning for a member of the Smith family? Well, they put in 1 gold coin and there were 10 total, so it's 1 out of 10. They have a 1 out of 10 chance of winning. And for the Jones family, well, they have a 9 out of 10 chance of winning. So this doesn't seem very fair. How can we improve this? Well, here are 3 possible ways that we could improve the situation. I don't mean to suggest that they're the only 3 ways to improve the situation, but they are 3 different ways. Scenario 1. Suppose the out-of-towner decides not to accept gold coins, but to have the initial lottery applicants able to apply for free, but only the winner will have to pay a gold coin. So now the odds would be even for the Smith family and the Jones family. Scenario number 2. An out-of-town judge arrives and intervenes and makes an order that the Jones family must pay the Smith family 4 gold coins, such that in the end, the Jones family will only have 5 gold coins, and the Smith family will only have 5 gold coins. Now, both families will have an equal chance of applying for the contest. A disadvantage of this scenario is that it takes something away from one of the families. An advantage is that by distributing the wealth equally between the Jones family and the Smith family, not only is that relevant to this context, but for any context in which gold presents an advantage. Scenario number 3. A generous benefactor from out of town arrives and gives the Smith family 8 gold coins. Now, the Smith family has as many gold coins to enter the contest as the Jones family has, so now the chances are even between them. Now let's review some of the assumptions about this whole thought experiment. First, we imply that there is some legitimacy in treating these families as opposed to as individuals. For example, in the first scenario where we eliminate gold coins having any value to the contest, and we suggest that the odds are now even between the 2 groups, well, actually, that says nothing about their populations. If the Jones family has 100 members and the Smith family has 10 members, well, then the odds are still going to favor the Jones family over the Smith family. In this way, population is another form of currency like the gold coins. It's another form of currency for advantage. But secondly, by treating them as families, we might imply that there is some kind of central authority for that family that decides which members have gold coins and which members do not. For example, if the Jones family has 50 members and they only have 9 gold coins, well then how are the members selected from the whole family as to who is going to be a participant in this contest? Are all 50 members going to agree on the 9 applicants from the Jones family? Same idea for the Smith family, obviously. By treating these individuals as families, we suggest that they are all aligned. But if we stop thinking about them as families, then if the Jones family has 50 members and 25 of them are interested in applying for the contest, those 25 can apply for the contest in the first scenario because gold coins don't have any value. And from the Smith family, if they have 5 members that want to apply, or if they have 1,000,000 members that want to apply to the contest, because we're no longer considering the families, every individual will have an equal chance of winning the contest for this first scenario, which doesn't require gold coins. In the second scenario, the judge orders that some gold coins go from the Jones family to the Smith family. Well, which individual members of those families are going to receive and give coins? For example, if the Jones family has 100 members and there are only 9 members with 1 coin each, then those 9 members have to give something up, and the other members of the Jones family don't have to give up anything. So they might feel that they're not treated fairly. Likewise, when the money arrives to the Smith family, who decides which members receive those coins? By treating these families as groups instead of as individuals, we assume that they're all aligned. Reconsidering scenario number 3, a pretty big issue is the reliance upon a generous out-of-town benefactor. If we were to try to compare this with a realistic scenario, as opposed to a mere thought experiment, we might imagine that this generous benefactor takes the form of tax dollars, or the pool of tax dollars. In this third scenario, whatever the cause of the inequality between the Jones family's wealth and the Smith family's wealth, we artificially introduce wealth to even out the chances across the 2 families. But once again, there's the issue of which members of the Smith family are going to receive the donated gold. Are they all aligned and they'll all agree? Now I'd like to talk a little bit about scalability. For the first scenario, if we imagine that there are 2,000 families instead of just the 2 families, in the first scenario, by removing the value of gold coins and having a pure lottery, then no individual from any family will have any advantage over any other individual from any other of the 2,000 families. So scenario 1 seems like a pretty good idea altogether. How about scenario number 2 for scalability? If there are 2,000 families, well, in scenario 2 there was a judge. So now we're going to need the judge to go through the wealth of all the different families and decide exactly how to add them all up and then distribute them all evenly across all 2,000 families. But once again, we're left with the problem of which members in each family receive the distributed wealth. Or are we guaranteed to have enough that everybody gets the same amount of wealth? And is there even an incentive for wealth if everyone has the same amount of wealth? If we were to answer no to that, then what's the difference between this scenario and scenario number 1, in which gold coins have no value? What about the administrative overhead of distributing all the wealth? There is no such overhead in scenario number 1. And how about scenario number 3? Now we have 2,000 families, and the generous benefactor from out of town comes along and examines each family's wealth and donates an amount to each family such that each family will wind up with as much wealth as the wealthiest family had in the first place. So if the wealthiest family has 12 gold coins and the first family has 0, that means giving 12 to the first family. If the second family has 6 gold coins, it means giving 6 to the second family. If the third family has 2 gold coins, that requires giving 10 gold coins to the third family, and so on, till everybody has 12 gold coins. So I'd like to suggest that considering these 3 scenarios of equaling out the chances between the Jones family and the Smith family are a useful way to think about situations that deal with equality. Can you think of any contests in real life that people think about as being unfair? The gold coins in this thought experiment represent advantage. An advantage can come in many different forms other than wealth. As I discussed, population is another form of advantage. If you have a majority and you have a minority, by definition, the majority has greater advantage than the minority in terms of population. So for any contest where population makes a difference, that majority is going to have advantage. And the only way to artificially introduce advantage to the minority is to equal out the numbers of both kinds of people. And when we're talking about populations, that means either halting the birth rate of the majority and increasing the birth rate of the minority, or I'm not sure what else you could do to equalize the populations. There are many forms of advantage. There's intelligence, there's adoration, there's property, there's ability, and there are lots of contests in which certain advantages manifest. For lots of contests in real life, we should be able to identify strategies that remove advantage where it's not warranted, and we should be able to identify which of these three scenarios those strategies most closely resemble: the absolute removal of advantage, the shifting of advantage from one group to another, or the artificial inflation of advantage in a group to match its advantage with another group. And why are groups important at all? Do the individuals within groups wish to be treated as being part of groups? What do you think? Can you think of any real-life contests where people have noted that circumstances are unfair and propose strategies for making those contests fair? Are you able to compare such strategies with the scenarios 1, 2, and 3 of the thought experiment that I'd offered? Please let me know. And if you enjoyed this talk, please consider subscribing, or sharing it with people who might be interested, or making your own response. Thank you. Goodbye.